Assalamualaikum and hi everyone. I would like to present about our group project of problems and limitation of epoxy and silver as conductive adhesive in electronic industry. My team members for this project are Cikgu Muhammad Farhan, Muhammad Nur Alif, Nurul Ain, Zuhaira, Intan Nur Aina and myself, Ainul Shakira. Okay guys, for next slide is about project summary. The main purpose of the project is on the properties of nanocomposites that are suitable for electronics, which requires the nanocomposites to be electrically conductive and thermally conductive. Nanocomposites are materials created by introducing nanoparticulates to as filler into a matrix material in the field of nanotechnology. Based on the research, the advance in conductive adhesive technology will be analyzed. This project will also explain on the material development of nanocomposites and its processing method. The theoretical formulation to obtain the specific mechanical properties measured also will be discussed. All of the specific test methods to characterize the materials in terms of their mechanical, electrical, and thermal properties will be provided. With all of the information that have been collected and obtained, it can be concluded that an epoxy and silver is the most suitable of materials formulation to be used as the conductive adhesive for the electronic industry.
Nanocomposite include materials with at least one physical dimension within the nanometer spectrum. Nanocomposite research creates a scalable framework from the creation of certain novel nanomaterials with diverse properties and functionalities. Electronic adhesives are central component of electronic components and are commonly used in the product and installation of a wide variety of electronic products. Demand for electronic adhesives are growing exponentially, leading to advancement in electronic devices. This improvement in the properties of nanoparticle is useful in many ways. Electronic adhesives definitely have their benefit, but it still cannot replace traditional thin soldering in many applications, particularly at high temperature, rendering it ineffective. Low impact strength, low reliability, and low conductivity due to reduction in bond strength generally occur on aging at elevated temperatures and under moist conditions. Adhesives are organic compounds and have lower thermal conductivity compared to solder interconnect. Most adhesives are non-electrically conductive and must be converted by adding a filler to the base material.
The next subtopic is nanocomposite. I will explain the definition and the application of nanocomposite. Nanocomposite materials has greatly grown to provide a wide range of structures such as one-dimensional, two-dimensional, three-dimensional and amorphous materials that produce at distinctly different components and combine at the nanometer scale. Nanocomposites are materials with a nanoscale structure that improve the macroscopic properties of products. The increment of nanostructure materials in recent years has been mainly due to their attractive potential, which is greatly enhanced in mechanical and physical characteristics compared to conventional grain materials. Nanocomposite materials can be classified in the following way based on the presence or absence of polymeric material in the composite. Polymer-based composite can be classified into polymer ceramic, inorganic polymer, inorganic hybrid, and polymer layered silicate. The nanocomposite in which the composition do not contain any polymers are called non-polymer-based nanocomposite. Non-polymer-based nanocomposite are also known as inorganic nanocomposite. They can be further classified into metal-based nanocomposite, ceramic-based nanocomposite, and ceramic-based nanocomposite. The example of the application that use nanocomposite material is artificial joint implants for fracture failures, dentistry, electronics and food packaging industry, various vehicle types like engine covers, door covers and timing belt covers, manufacture and structural repair of damaged oil and gas pipeline. High performance of nanocomposite are also used in fuselage seating in aircraft. Other applications are used as blade for vacuum cleaner, mobile hood and covers for mobile phone. Nanocomposites have been growing with a speedy rate so as there are large number of applications. In the future, the worldwide production will increase in the following regions: superior strength fiber and films, UV protection gels, drug delivery system, new fire retardant materials, anti-corrosion barrier coatings, lubricant and stretch film.
Next is materials development. The synthesization of silver epoxy nanocomposites plays an important role in manufacturing of nanocomposites. The shape and size of nanoparticles need to be determined as it may affect the thermal and electrical properties of that composite. Meanwhile, the optimum content of the filler is crucial in maintaining low density and high mechanical properties provided by polymer matrix. The thermal conductivity increase with silver content and the influence of filler aspect ratio is significant. According to Hostavan et al., interfacial interaction between host matrix and nanofillers is a parameter that must be taken into consideration in order to achieve desired thermal and mechanical properties. In situ technique has been used as a processing technique for the preparation of epoxy silver nanocomposites. This technique involves two main steps, which are the preparation of silver imidazole, and the second step involves the preparation of epoxy silver nanocomposite itself. The silver imidazole complex was synthesized by silver acetate and 2-ethyl-4-methyl imidazole, which is known as 2E4MZ, which act as a reducing agent for silver. Imidazole was immediately released from complex and could initiate the curing reaction of epoxy resin. The silver acetate was added to CH2Cl2 solution of 2E4MZ, and the mixture was stirred for 2 hours until all silver acetate solid disappeared, and the solvent was condensed to approximately 2 ml. Then ether was added to give white precipitates, and the solid was filtered off and collected. The product was obtained as a white solid after recrystallization by dichloromethane diethyl ether with a yield of 85%. Next is the preparation of silver epoxy nanocomposites. The silver acetate and epoxy resin with the fraction ratio were distributed in acetone. Since silver acetate does not dissolve in acetone and only in suspension, an acetone solution of 2E4MZ was slowly injected into the above suspended mixture to dissolve the suspension, and after being stirred for 30 minutes, the solvent was evaporated under reduced pressure at 40 degrees Celsius, and at this point the formulation was free of solvent. Finally, epoxy silver nanocomposites were obtained after curing at 150 degrees Celsius for 3 hours. This figure shows the overall process of reaction of producing silver epoxy nanocomposites.
For material characterization, this is properties for epoxy and silver in terms of electrical conductivity, mechanical and thermal conductivity. As we can see, epoxy is good insulator, high strength, versatile and low conductor. For silver, it is good conductor, ductile, malleable and good conductor. To identify the properties of the material, including electrical, mechanical, and thermal conductivity, a variety of tests were carried out. Specific testing method. For electrical conductivity testing, first we ask for surface tracking, which is the propagation of an electrically conductive path because of the breakdown of the insulation material along the surface of an electrical insulator. Second, dielectric strength is the maximum electric field strength that an insulating material, a dielectric, can withstand without experiencing a failure of its insulation properties breakdown. Finally, a coronal discharge is an electrical discharge brought about by the ionization of a fluid surrounding a conductor that is electrically energized. For mechanical testing, mechanical testing, also known as a destructive testing, reveals the properties of a material under dynamic or static force, designed to ensure that materials are suitable for their intended application. Mechanical testing includes methods such as tensile strength, compression strength, impact resistance, fracture, and fatigue. Element tensile testing lab provide conditions for exposing material to a static or slowly applied force, determining their ultimate tensile strength. Tensile testing is a destructive mechanical testing method that subjects a sample to uniaxial tension until failure. For thermal conductivity testing, the steady-state technique records a measurement when a tested material thermal state reaches complete equilibrium. For non-steady state or transition technique, record a measurement during the heating process. The method determines thermal conductivity properties by means of transient sensor. To determine the mechanical properties of the material, tensile test is the best selection. A tensile test, also known as a tension test, is one of the most fundamental and common type of mechanical testing. This is stable for theoretical formulation for modulus of elasticity, shear stress, and strain.
Next is conclusion. So, as the conclusion, epoxy resin is the most appropriate adhesive to be used in the electronic industry. Epoxy is the one of the glycidyl groups that can be held by the creation of useful material. Besides that, epoxy resin also one of the most used polymers in the manufacturing field. Other than that, with the combination of specific characteristics such as thermal conductivity, dielectric constant and ductility, starch resistance and modulus, toughness and wear properties, impact efficiency and compressive strength, and also composite with polymer matrix (PMC) can be displayed. UTeM analysis shows that the addition of epoxy and MDA plays a role in controlling the size and dispergolation of Cu nanoparticle. Compared to pure unfilled epoxy or MDA, a small decrease in thermal stability is observed for Cu epoxy or MDA composite. Lastly, the problem and weakness of epoxy and silver as a metallic filler used for the electronic industry was finally solved in this research.
That's all the presentation from our group project. Thank you guys. Assalamualaikum and goodbye.